Configuring a tool chain for AUTOSAR is a very crucial step, and here I'll explain some of the steps to achieve this. So basically the steps involves to develop, compile and test your AUTOSAR components. And here's the general guide, not much details, but this is the general step which you will need for configuring toolchain in AUTOSAR. So the first is you need to select the appropriate tools. So the main are the IDEs like Eclipse or DaVinci Developer for Vector or EB-Tresors Electrobit. So these are some of the main integrated development environments where you can compile your code and you flash it, and everything can be done in the system, in the whole IDE. Compiler and build tools is compatible with your target microcontroller such as GCC, IAR or Greenhills, and compilers can also be integrated with the IDEs, and that's some of the things which you need to set up. AUTOSAR authoring tools is tools for generating AUTOSAR compliant code and configurations like Vector, DaVinci Configurator, Electrobit, EV-Tresors or AUTOSAR Builder. Static analysis tools for code quality checks like Polyspace and PC Linked. These are some of the tools which test your code for static analysis. There are certain rules, like for example, Polyspace has different MISRA standards which you can set, and then depending on that, it will check whether your code matches these standards. If not, then it will either throw up a warning or an error which you need to fix and then rerun. Then you have the debugging tools like Lauterbach or JTAG debuggers, which are used for debugging bugs. So these are the initial set of tools which you need to start configuring or setting up. So the next would be to install the tools, like you need to download and install it and make sure that the tools are compatible with each other, because many of the tools they have different versions and they have to match with the appropriate versions to get the things working. And then you need to set up the environment variables, configure the environment variables to the point to the installed tools. Basically, when a tool is installed, it will be at a specific location in your C programs or certain path, and that path is the environment variable path of that, and that has to be added to the path so that the system recognizes. So this includes the paths to the compilers, build tools, and other utilities. Examples like C path to the compiler or C path to the build tools. So the next would be to configure the AUTOSAR BSW module. So this will be the main part. Is next step is configuring the AUTOSAR-based software module. So the first is you need to import the BSW module. Use the AUTOSAR authoring tool to import and configure the BSW modules. This typically includes modules for communication like CAN, LIN, FlexRay, diagnostics for UDS and operating systems, OSEC and VDX or AUTOSAR OS. Then once you import it, then you can generate the configuration files. Use the tool to generate the necessary configuration files like AR, XML files for the BSW. So this is configuring the BSW tools. That will be the step which you need to do initially. Next, develop application software components. These are the components which the user develops based on the AUTOSAR, which can run on the middleware platform. So creating software components, define and develop your application level software components using AUTOSAR methodology, and configure the runtime environment. Generate RTE configuration using authoring tool, ensuring that the communication between the software components and the BSW's modules are defined. So basically, when you say software components or application software components, it is your code which will basically control a specific hardware. But the thing is, it will be it should conform to some of the standards of AUTOSAR code conditions, and that is what you say application software. It is your code or C code or generated code which basically conforms to a specific standard. So that's what is application software components here. Then set up the build system, create a build script, set up a build script like makefile or cmakelist or ID specific project files, which is responsible for building or compiling the code. So paths to which includes the paths to all the source files, include directories and libraries. That is also makefile is. And then compiler flags, ensure correct compiler flags and settings are configured for optimization, debugging and compliance with safety standards. So you set up this make or compiling setup so that it grabs all the code and compiles and generates an executable system. So this is some of the standard process in other systems also, but here the only difference is that you're using a middleware where AUTOSAR, that is, it has a preset sort of code or middleware code which is available upon which you build your code. So that's the main difference. Then build the project, that is, you normally use make all and use to configure build script, and once it is built then you can link it. That is, when you compile you have a lot of object files, or these all files will be linked together to get you the final binary or executable. So compile and link, then will be the static code analysis and testing. Run the static analysis, use your static analysis tool to check for coding standards, compliance and potential issues. After you run the static analysis and fix the issues, then you will be having the unit testing, performing unit testing involved, which involves the individual software components using suitable frameworks like Google Test Unit or C Unit. You can use the unit testing. So flash and debug. Flash the microcontroller using flashing tool compatible with microcontroller to load the compiled binary on the hardware, and debugging using a debugger to test the application, to test for hardware and set breakpoints. For example, when I was working in a car steering as a system, so once I flash the software on the motor or hardware, then you can connect it with different debugging systems like Canalizer or Canopy. For example, in Canopy Canalizer, you can monitor and analyze CAN bus communication, debug ECU, real-time ECU data, and then simulate different issues with the network nodes. With Canopy, you can change parameters on certain stuff. Like once you connect with the hardware, you can change some parameters and see how the system reacts, can do the data logging and those sort of stuff. So here I'm going to quickly give you an example configuration for simple AUTOSAR toolchain in a very short fashion. Here's a simple. First is install DaVinci developer configurator, download and install from the vectors website, set up the licensing. Then will be install compiler, download and install the compatible compiler such as tasking compiler, which is typically used for automotive applications, which is compiles the C code and generates the binaries. Environment variables. Next, set environment variables for the compiler and the vector tools in your system. And the fourth point is create a new project in the DaVinci developer, create a new AUTOSAR project, define your software components and the interfaces. Fifth point is configure the BSW in the DaVinci configurator, import necessary BSW modules, generate the configuration files. Then generate RTE. DaVinci developer generate the RTE based on the defined software components and the base software configuration, runtime environment. Then build the project using use the build function in the DaVinci developer or an external build script. And finally is the flash and debug. Use vectors flashing tool to program the microcontroller using, and then debug using compatible debugger. By following these are the steps, adjusting according to your specific tool requirements, you can effectively configure and manage AUTOSAR toolchain. So this is, I have taken specific, for example, DaVinci developer and configurator, and just jotted down the steps which you need in if you are using this set of toolchain. This is an example of how you can go from beginning to the end in the case of AUTOSAR configuration. Final will depends on the company. You have the continuous integration. Some companies have it, some companies do not. And if you have the continuous integration, you can use the tools like Jenkins, GitLab or CI Bamboo, which can be used. Basically what it does is once you check in a code in the version management system, it just pulls up and then compiles and generates an executable, and you don't have to run or make or manually. Some companies do use it manually because the codes are so energy intensive, like it needs some manual intervention. Some companies don't use the CI/CD. There you don't have to set this up. But if you are using CI/CD, or if your company is using it, then tools like Major will be Jenkins or GitLab will be commonly used.